Hi, welcome to this video. Today's video we are going to give a general definition of derivation. Derivative is defined as instantaneous rate of change or slope at a specific point of a function. Let's move on to see the graph and the tangent slopes. Okay, as you see, the function is going up, is increasing and changing the direction as you find more slopes. Okay, so I have chosen 3 examples of slopes. I have chosen this one, and second one and third one, which is going parallel to axis or x. Okay, and then I transfer this information into 3 aspects where we see more details. Okay, before we start calculating our derivative at a particular point, which is this one, we have to make definition of slope first. Okay, what's the slope mean? Slope is noted as by m equal change in y over change in x equal rise over run. That's the definition. Okay, is equal, which is m plus this changing in y is this distance f of b minus f of a over this distance b minus a. This distance equal b minus a. Okay, so let's transfer this information to this one in order to find derivative at the point which we want. Okay, specifically at x. Okay, so in order to do that, let's write this one as you see it here. Okay, same thing. So what to do? What to do is m equal what? Equal f x plus h minus f of x over x plus h minus x. Okay, so we are doing the same thing here, just we are changing in y, which is this distance f of x plus h minus this distance equal this distance minus this distance, which minus f of x, changing in y, which is this one, over changing in x, which is x plus h minus x. Don't look at this picture because this picture just theory study. Just the important thing here, we show you this distance is x. X could be anything. It is a number. H is a number as well. It's just distance. Now the difference between the first picture and second picture, this one, to do the slope we have to choose 2 points, right? The same thing here, we have chosen 2 points, but we are not care much about 2 points. We are care about the point which we want to derivate our function at a particular point. Okay, so that's what we want. In order to derivate our function at this point, which is x, so we have to move each towards x, which is we move x towards 0. Okay, this is distance. If you move each towards x, this triangle become more smaller. Okay, very small until you get 0. What to do to make that? We have to apply the limits when each is approaching to 0. Okay, that's what I'm trying to do. So we have to apply the limit. So m limit each is approaching to 0. If this each is approaching to 0, so that's mean each is almost equal the x. Okay, so that's mean each is approaching to 0. That's mean the point here, the second point we have chosen, it become almost the same, the point where we want our the derivative point. Okay, so you are going to cancel this one and this one. So what's left? Limit f of x plus h minus f of x over h is approaching to 0. Okay, This is our definition of the derivative at the point x, okay? This one is valid for all x as long as you have a continuous function, okay? Okay, and then it's not just all, sometimes you find the points where your function is not derivative at particular points. Okay, there is some cases we have to mention that. So this is the function. Our function is derivative at the point x, which we just calculated now. You see it? So this, when I'm talking about this one, that's mean I'm here too, the same thing, because this one just make it bigger to make everybody understand. Okay, so we have to see what is this. Our goal. This is f prime of x. This is our goal. Okay, f prime of x. So what to do next? Next, we are going to see the cases where our function is not derivated at some points. Okay, let's see one example here first. So this example, we have origin a o or a j. So if you have this function, for example, okay, and then what happened here? And then your function skip into here, for example. This is the function. As projection, this is, for example, x1, right? Take a look at here. You see the image of this function f of x1. For example, this is f of x1 2, but this one is give you different number. Okay, give you different number, but this one give you positive. Look at here. What's the important here? Your function. This is the function, the same, but it's not continue at the point x1. Okay, as long as, since your function is not continue as at the point x1, so that means it's not derivative at the point x1 too. Okay, so this is first example. Let's move on to the second example, where your function is not derivative. Okay, for example, if you choose this point like this, your function going like this too, and you see your tangent. This is tangent. This tangent is vertical. Is a vertical to OX. Okay, the axis OX, parallel to OY. So what does this mean? We can transfer this information here to understand what it means. Yes, you see this slope here. If you change direction, this alpha, this is angle, go to pi over 2. This means become vertical, right? That's mean your angle is going to pi over 2. What do you know about your tangent, the pi over 2? When a tangent pi over 2, it goes to infinity, plus infinity. What does it mean? That's mean your limit f of x plus h minus f of x over h going h when x is approaching to 0 equal infinity plus infinity. That's mean your function is not derivative at that point, at this point. Let's call it x2, for example, right? This is the example where your function is not derivative. Okay, third example, your function is derivative but equals 0. Where? At this slope. Okay, because the slope, when this alpha go to the 0, that's mean tangent go to the 0. That's mean your this equation equals 0. Okay, if your slope is parallel to the axis OX. Okay, that's mean this one is 0. Okay, now let's move on. let's move on to examples. Okay, first example, for all x for x is a real number. Okay, x is a real number. Okay, f of x equal x squared. We are going to calculate f prime. Okay, how to find f prime? Let's use the same rule of the limit in order to find f prime. Okay, so that's mean limit f of x plus h minus f of x over h, this one minus this one. Where is h going to 0? So let's apply the same rule. So this one equal x plus h. Let's apply the limit because we are using the limit here. X plus h square, square minus f of x, which x square over h, where h is approaching to 0. Okay, so the limit, this one, x square plus 2xh plus h square minus x square over h. Let's cancel x square with x square. What's left? So our limit of x plus h minus f of x over h, where is h is approaching to 0. Let's factor h. Factor h equal 2x plus h over h. H is approaching to 0. You are going to cancel h with h. So your limit is 2x plus h. Where is h approaching to 0? Let's plug in 0 into h. It gives you 2x, which is a prime of x. That's what I'm looking for. Okay, so f prime of x equal what? Equal 2x. Okay, now it's very clear. So let's to make everything okay. So let's to go to the next example to see what's the difference. Okay, and to make this very clear, and then we add another example. So let's put f of x equals square of root of x. Where is x is positive, greater or equal 0. We are going to calculate the limit. So the limit of f of x plus h minus f of x over h, where is h going to 0, right? So this one it gives us square of x plus h minus square of x over h. Don't forget, here is limit minus of x over h equal limit h go to 0. Here be careful. Before you start doing anything, change this form, you have to apply the limit first. If you find your limit is indeterminate value, you have to change the form to another form where we can see more simplification in order to get your limit calculated. Okay, so let's apply each, plugging each into each now. So what's given you here? Give you this one, give you 0. Give you x, which is give you so gives you 0 over 0, because you play in each, which is 0. Square root of x minus square root of x is 0 over h, which is 0. This is indeterminate form. Okay, you should change another form to calculate your limit. Okay, when you see the square root, always most of the time you are using the conjugate. Okay, let's do the conjugate now to solve this one, to end with this one. So let's start with this one. What is x plus h minus square of x over h equals square of x plus h minus square of x over h. Let's multiply this one by x plus h plus square of x. Okay, this one, as I'm applying this one on the top, I have to apply this one on the bottom as well. So x plus h plus square of, okay, I'm doing nothing here, just we're dividing this one over this one, which is 1. So we multiply in this our form in order to change this form to get new form where we can calculate our limit easily. Okay, let's multiply this one. This one gives you x plus h. This is identity I minus b, factor a plus b equal a square minus b square. Okay, so it gives you minus x over x plus h plus square x, right? Let's cancel x with x. This one gives you h, and then you are cancelling h with h2, 1 over square. This is what's left. Now when you are applying your limit, okay, on this one, which is 1 over x plus h plus square root of x, where h is going to 0, let's plug in this one into h. It goes to 0. What is left? Square root of x plus square root of x, which is 2 square root of x, right? So your limit is 2 square of x. What is this one? This is f prime, that's what I'm looking for. So for all x superior or equal 0, your f prime equal 1 over 2 square x. Okay, this is your limit. This is f prime is calculated. So I think everything is clear. Okay, thank you for watching. I see you in next video. Bye.